All right, Patriots, let's get started on this review for our circles unit. We're going to start off and do all three of the true-false questions at the beginning in one video. Now, one thing I strongly suggest you do is make sure you're being very careful with all of the vocabulary words in here. Make sure that when you see things like radius and semicircle and chords, secant, tangent, you know exactly what those are talking about. Make sure that you have gone over all your vocabulary and you know what all of those different parts and segments of a circle are. I also recommend, number 2, draw a picture of each of these before you make a decision. The picture will help you out tremendously. Now, you're only going to be able to draw the picture if you know what all the words mean. So that vocabulary is extremely important. Now, number 1, a radius is a segment of a circle connecting the center of circle to any point of the circle. So we've got a circle. We're going to connect the center. And then it says any point, so I can just pick one and then connect those two. And yes, that does look like a radius to me. So remember, a radius is exactly half the diameter. That one is going to be true. Now, number 2, a triangle inscribed inside a semicircle. Now, let's go ahead and make a semicircle here. I can use the exact same drawing from earlier. I'm going to go ahead and complete that diameter to make a semicircle. And it says a triangle inscribed inside a semicircle. So let's go here and let's bring it down to the edge and then back up. Now it says that that's an isosceles triangle. Remember, isosceles means that two sides or two angles are identical. Now, one of the properties that we learned about inscribed angles is that they are exactly half of their intercepted arc. So over here, since it's a semicircle, this intercepted arc is 180 degrees, meaning that this inscribed angle is going to be exactly half or a right angle. Now, it wouldn't matter where I put it. If I put it here, it would also be a right angle. Now, there's no way to guarantee that any of these or either of these two are going to be equal to each other in order for it to be isosceles. So this one is false. Now, if this instead had said a right triangle, then that would have been true. Number 3, two congruent chords have in the same circle have congruent arcs. Let's see, if we have a chord here and a chord here, these two are congruent. The question is, are these two chords congruent? And yes, that is true. That is one of the properties that we learned about our chords and their arcs.